Hi. Today we're going to talk about, I'm going to call that 5 points on the trajectory of a projectile. So I'm going to draw the velocity acceleration at this 5 point. So let's say if you have a projectile that shoots out like a football or like a soccer ball on a level ground. Okay, not too bad. I'm changing color. So I'm going to draw 5 point, point 1, point 2, point 3 on the top, point 4, so same height, right there, point 4, and then, so this is at the beginning. So this is right before you strike, right before you hit the ground. Okay, so first velocity. So velocity when this guy, so you're going to draw a tangent, okay? So tangent, so that we're going to call that V1, and I'm going to call this one V1x. So x and y. So that define your horizontal and vertical, so positive direction. And 2. So 2, you can see this angle change already. This is theta 1. You can see this one here, the theta 2 is less. Okay, I'm going to call this one V1y right there. V1y. Okay. And I'm going to call this one here V2. Call that one V2x. So V2x will be the same as V1x if there's no air drag. So we say no air drag. And then V2y. So V2y is here, and V2y will be less than V1y. Okay. There's no air drag, but due to the gravity, right? And here there will be no, there will be V3y will be 0. So this is V3x is equal to V2x equal to V1x, right? So V3y, it's equal to 0. And here, I'm going to draw a tangent again. This is a tangent to the trajectory. So this is V4x, and that's the same as V3x, and so on and so forth. And then now you have this V4y. So V4y, the magnitude is equal to V2y, but it's in a different direction. So V2y is going up, but this is going down. So it's opposite. And now, right before it's hit the ground, it still has velocity. So it's still a tangent. And we're going to call this one here. Right. So V phi x. V phi x is equal to V4x. And is equal to V3x, V2x. Right. And this one here is going to be V phi y. Right. So the absolute of that is equal to V1y, because they are at the same vertical height. All right, and then let me add the A, right, acceleration. So at all this point, the A is going down and is equal to minus 10 meter per second. And right here, right, so this is A1 and this is A2, right? So A2 is equal to minus 10 meter per second, right? And A3, right, it's still equal to A2 equal to A1, right? Still minus 10. And A4, same, right? Going down, and it's equal to minus 10. And A5, same thing, right? A5, right? Let's look at X. So I'm changing color here. Let's look at X now. So let's say if right here it's my origin, okay? Treat that as an origin. That's origin. So for this point, this is the displacement right there. So that's your x1 in the x direction. And right there, that's your right, x, sorry, well, yeah, we call the x displacement. X2, oh, sorry, this is x2 in the y direction. This is 2, right? So at that point, we're going to call that 2. So x means, the first x here means displacement, right? So displacement in the y position at this point 2, so called x2y, right? And this is called x2x. So similarly, for this one here will be called x3x, right? So this is the x component, right? So this is equal to the x component of displacement at point 3. Okay, and then y will be right there, right? This is the x3 in the y direction, right? So this is the y component of displacement at point 3. So I'm not going to do 4 and 5. So we're going to stop here. Thank you. And I'll see you next time. All right, bye-bye.